cloud, no?
Okay, now we are recording.
Okay. So thank you again for your organization for inviting me, and I will begin to share the screen to begin the discussion. I will be very concentrated, very synthetic. One second. So, are you able to see the?
Yeah.
One moment. Okay. So, okay. Thank you to Stefano, who was invented this beautiful title for this spoke, because in effect he was able to understand the fundamental principle of this new mechanism. So first, I want to tell to you that I am the CEO of Promete. Promete is a micro company that was founded in 1997 in Napoli, and it became a spin-off company of the National Research Council after 2 years. It is, but we are totally private. We are not inside the research, the National Research Council. This is important for me. Our activity is related to technology transfer. And this is a very interesting example of missing technology transfer. You know that probably you know that Leonardo was invented the ball bearing for more than 500 years ago. And after 400 years, it was invented again because its manuscript was lost. So this is an interesting example of missing technology transfer. So our principal activity is related to this. It is very difficult to describe in its particular. During this activity, we were patenting many inventions. We were also publishing many international research papers in the field of physics, especially. But our activity is related to technology transfer. This is, I want to ask to you if you know what is this. This is not a modern artwork. This is not what a boy was doing with some Bostik, with some glue. This is the first transistor. The first transistor was something like this, a macroscopic ensemble of 3 pieces of materials that was behaving in a strange way. And it was impossible to understand at the moment. Only quantum physics was able to describe this phenomenon. And this is the origin of the modern microelectronic revolution. So I want to tell you first, very shortly, what is the modern vision of liquids. What we studied at university is that liquid is something incoherent, something disordered, not ordered. But from quantum electrodynamics applied to the ordinary matter, normally quantum electrodynamics is applied to so-called high energy physics, that is the physics of particles. But when some scientists were able to apply quantum electrodynamics to the ordinary world, they understood that it is the only way to understand, for example, the transition from gas phase to liquid phase. But the very interesting fact is that in this way, the description of the liquid phase was totally different. So it came out that liquid phase is not, it's something biphasic. That is, there is a matrix of incurrent phase very dense vapor, and there are some coherence domain. Inside this coherence domain, the water, for example, water, but this is true for every liquid. In particular, this is very important for water. Why? Because in this coherence domain, the molecules are oscillating spontaneously among two energy levels. In particular, in water, the second energy level is very, very near to the ionization energy of the water molecule. Why this is very important? Because normally liquid water was considered an insulator, totally not able to transport electrons. It is not like a metal, also not a semiconductor. It is an insulator. But this is not true, because this is true for the molecule when it is in the void, when you have, for example, a gas water molecule. In the liquid state, this new vision is able to understand that the second level in this coherence domain is very, very near to ionization energy. This means that you don't need more 12.60 electron volt to extract one electron from the water molecule. This means the energy of the X-ray of thousands of temperature degrees, but only 0.5 electron volt, half electron volt. This means the energy of the infrared range. This is the important consideration. So, for example, in the 50s, Albert Szent-Györgyi, the Nobel Prize, who was understanding many biochemical reactions that are able to in such a way to understand many biochemical reaction happening in our body, he was saying, okay, I was able to describe very well these biochemical reactions, but this biochemical reaction needs a lot of electrons. So I don't know from where they are coming. He said, probably the only origin may be the water, but I don't know how this is possible. Now we understand how it is possible, thanks to this new vision of liquids, and in particular of liquid water. This is the schema I was explaining, not the scale. These are the theoretical physicists that were able to understand this new vision. Emilio Del Giudice on the left and Giuliano Preparata on the right. I was very lucky to know them and to collaborate with them. Here we can see on the left Vittorio Elia, and in the middle Martin Flashman and Emilio Del Giudice on the right. Here we can see the second person on the left is Giuseppe Vitiello, another theoretical physicist who was giving many important contributions in this field. In the center, there is Elena Napoli. She was working together with Vittorio Elia for many years to understand many interesting facts that now I have no time to describe in every detail. So I am describing shortly only the oxhydroelectric effect that we were patenting. Why we were patenting? Because it is something very strange. I will describe to you the experiment. We have two semi-cells, macroscopic semi-cells that you can see, in which we put in both sides pure water, bedistilled pure water. In the middle, there is a nanometer size filter, and on the right and on the left, we have platinum identical electrodes and connected to a resistor of about 50 kilo ohm, and we are measuring the tension at this resistor. So, as every child can understand, this mechanism is not able to perform electrochemical reactions. Nothing has to happen because we have pure water without electrolytes, without salts, without acids. We have two identical platinum electrodes, so nothing is happening. In effect, this is true. But if we only are producing a physical asymmetry in this system, for example, in this case, you can see on the right that I put some piece of Nephion. This is a polymer similar in a certain sense to Teflon that is totally totally inert from the chemical point of view, not able to perform any chemical phenomenon in water. It is only, I put in water only because it is very hydrophilic. The hydrophilicity is a physical phenomenon. In effect, it is an electrodynamical phenomenon. So this is interacting locally, but not so locally because it is a macroscopic system, as you can see. And this asymmetry is generating a region of liquid water where water is, in a certain sense, more ordinated. And it is able to give more electron than on the left. You can see the schema, probably it is more clear. You can see in this case, you have the Nephion on the left and nothing on the right. So there is a physical, only physical asymmetry. This physical asymmetry is able to interact with the water, the liquid water that has that kind of organization I showed to you before. In this way, we have a region like in a certain sense it is happening in silicon. On the left, we have electron donor zone. Much more electrons are able to be extracted. In comparison with the right region, where there is an electron acceptor zone. Less electrons are able to detach from the molecule, so it is able to accept electrons. This is very interesting because this was also a demonstration that liquid water is a kind of semiconductor, and the electrons are in this situation are the transportation, the charge transportation subject. We were also publishing this, and after this publishing, we obtained the patent that we presented before the publishing, obviously. Then we were doing some advancements. We were doing something more smaller. And this is a small cylinder in which we put two kinds of hydrogen. The hydrogen is only a way to interact differently with the water, exactly to obtain the same result than before. Then we put not platinum, but graphite electrodes. And this new version, it is a cheap version, small version toward the engineering result. If you have some time, I can give to you to show to you a small video. No. Okay, if I will finish the discussion, then I will show to you later. The important thing is the following, that we have a density of energy of a microwatt for cubic centimeter. No? This is the power of that small system. This means that if I put many cells in a cubic meter, I have 1 watt for cubic meter. But this means also that if I am able to realize a cell of a cubic millimeter, I am able to obtain 1 kilowatt for cubic meter. This means the equivalent, if I put 3 of these systems, I have the equivalent of this kind of surface covered by photovoltaic cells. A tennis field covered by photovoltaic cells. So this is not simply a curiosity phenomenon, but it is something that already now is very near to the application. Why this is very interesting? Because this is available all the day, because it is working thanks to the infrared radiation. So it is working also in the night. Also, for example, if you hide the heat in a wall, or if you are performing a wall made by these cells. Imagine to have 3 walls in a house made by these cells, 3 cubic meter, you will have 3 kilowatts. It is scalable in the sense that we will produce small systems, but obviously you can obtain large systems. You can use everywhere. Imagine the material of these systems is based on water. So it has a very low environmental impact, no? Low cost, because the materials are very cheap. So this is the idea that we want to release. We want to realize and to release. Recently, we made this startup. Sorry. We made this startup with this team. We have also Giuseppe Vitello, a scientific advisor. We are based in Napoli. And related to this new phenomena correlated to water, in effect, we have also other interesting patents, but now we have no time. I was publishing an Italian book on these topics, and recently many international researchers were beginning to speak about these findings of us. For example, Mai Wano, in his book Meaning of Life and the Universe Transforming. For example, Vladimir Voikov and Konstantin Korotkov in the Emerging Science of Water. They were speaking about these results of us. And also Fabio Fracas in his book, Italian book, Il mondo secondo la fisica quantistica. The world following quantum physics. Okay, I think that if you finally, I want to show to you the video to understand how the phenomenon is behaving, because it is interesting to give a look to the how it is behaving. I will open the video. 1 second. I have the video here. One moment, I will share to you. I have to share to you. I'm not sharing the screen now, right? True?
We see your video now. Okay.
Are you able to see the video now?
Yes.
Yes.
No, okay, this is not the video of the... Okay, let's start. This is not the video, one moment.
Mm.
No. Okay, let's go on, because otherwise we were losing time. One moment. Okay, now it is not shared, the scale, no? It is no more shared, okay?
No more shares.
Okay, so let's continue, because yes, it is, in any case, I will send to you the presentation, and there is inside a link with the video showing the experiment in such a way that you can see how fast it is reacting to, if you add more infrared light to the ordinary temperature heat in the room. It is working with the ordinary heat in the room, but if you add additional infrared light, it is extracting much more current. This is what I wanted to show to you. Okay.
Thank you very much, Roberto. Now, in a normal condition, I think we would have, members of the international press listening to your speech, etc. I'm very happy to do that among friends, because probably it's the first time you speak to somebody who is not into physics, and so most of the people here usually in our webinars come from the social activity, urbanism, architecture, etc., etc. I think your discovery is going to revolutionize totally the landscape, also architecture and design, and especially the distribution of energy. That is a key aspect of cities nowadays. No energy, no cities. We see when we have blackout now in the situation of shortage of electricity, etc., and this can be a disaster for cities. So the first question I would like Sergio Los to give you a question, because I think he reflected already about your discoveries. Yesterday he was sending me a few notes. He always even wanted to make a presentation about it. Of course, we don't have time, so he limited himself now to give a couple of questions, I guess. But we will meet later for something more related. Also, we had a previous meeting with the National Society of Bioarchitettura, the Italian society. They are very excited about this subject because they understand the potentiality of having free energy, autonomic energy for cities and even houses. Sergio, up to you.
Yes, I think that it is a very, very important discovery, and that is also a way for enhancing the value of bioclimatic architecture, in the sense that if I imagine the device explained by Roberto Germano as a black box, it is I put inside water, and it is supplying electrical energy. But if I have to climatize buildings, it is not the best way. We have heat pumps, we have the possibility of radiation, direct radiation, but it should be very expensive to climatize only by electrical energy. But the question very important is that if I design a building which is fitted to the local site, I need electrical energy for making usable the bioclimatic climatization, making answers for some periods in which it should be very, very expensive designing a bioclimatic building also for the peaks in summer or in winter. And so instead, the electrical energy supplied by the boxes filled with water of the Roberto should be perfect for these peaks, and also, of course, for supplying the electrical energy for many uses in the house as lighting, and also for many other activities, of course, that require and the enormous advantage of this device is that it is supplying continuous electrical energy, and so it is not requiring batteries with many problems of rare materials for realizing these batteries, and also for the pollution of these materials. As lithium, there is now a big discussion because China has very good reserves of these materials. So I think that in the field of architecture and the city, it is very important also for many places, low infrastructure, so with difficulties in keeping this the electrical energy needed for inhabit these areas. But the other important aspect is that its characteristics is to be very decentralized. Now we are building a very centralized world, not only because it is impossible to decentralize, but some difficulties in making it. But instead, with invention of this special device fed by infrared, so active in day and night, I think that this decentralization is the best answer for inhabiting many parts of the world. And so I think that it must be studied as a technology, but it is very fundamental. So if I describe it in very elemental terms, the material for building these boxes, which have inside the water, could be every materials, or are they rare materials? the technology of building these boxes of 1 meter for 1 meter for 1 meter, these cubes you have shown before, could be steel, could be metal, could be, and the water inside is water, so I can keep it from the rivers, from every place with the water. So I would ask to Roberto, what is the difficulty? Because it looks so easy that perhaps it have some question that could make it less so special, so easy, so from many aspects.
Okay, so we have these 3 questions practically from Sergio. Do you want first to have a question from Martha and then answer everybody, Roberto?
It's better to begin to answer. I think that is very interesting what Sergio was saying. In particular, I want to say that there is a side effect, because, you know, if this system is using practically thermal energy to extract electrons, this means also, but we were not measuring precisely, but conceptually, this means also that the system is cooling the environment. Because otherwise, this is first, but it is a side effect. But it is very interesting that we have to go deeply in this effect. Second, it is very interesting to understand that this is something very similar to biological mechanisms. In particular, I think, and also Emilio Giudice was thinking, that the principal energy in biological systems is coming from phenomena like this. For example, it is possible, this is an idea, we were not exactly showing this. This is an idea, there are many clues pointing in this direction.
Chiedo scusa Sergio, credo al tuo microfono non si sente la voce di Natasha.
Yes. No, scusate voi.
So we think that biological systems know that we're discovering this effect many years before me. I think this is obvious. And this is very interesting because this means that we have to go deeply also in understanding of biological mechanisms. When you understood that this physical effect, it is possible to understand better biological mechanisms, and in such a way to understand better how to use the system. And this is another point. Another point is very important, the decentralization that will be possible thanks to the system. Then Sergio Los was asking about how to use this mechanism. Considering that it is connected among us also another associate of Oxy, if you agree, Stefano, we can give to him, Graziano Terenzi, to speak about this question of Sergio Los, a few minutes, 2 minutes, to if Graziano is, as I see, is connected, he can comment 2 minutes this question of Sergio Los about the technology.
Then there is also another question coming from Professor Guido Dalla Casa, who is an
okay, yes, I was reading, yes.
That's very interesting as well.
If you read, I will answer.
Professor Guido Dalla Casa is is an engineer in in electricity, if I can use the term. So he's an expert in the subject, and also he's an expert in deep ecology. And he asked if there is any chance that this is an instability phenomenon. Sometimes happens, sometimes it doesn't. So if there is a certain stability.
The question is very clear, and the answer is no. It is not an instability phenomenon. For this reason, one of the reasons why we were waiting about 10 years before deciding to do a startup, because we were monitoring for months the same systems in the simple beaker with electrodes and so on. It was going on for weeks, months, and so on. The only problem is the evaporation of water. And from another side, the materials that can a little suffer from the environment. But the phenomenon is very, very stable. This is very interesting. We have no doubt about this. In effect, we were patenting, and the discussion to patent was not so easy, because every person, starting from 11 years old child, can tell to me that it is impossible. And all this, but this is not, it is very stable. This is very interesting from this point of view. Yes.
So Graziano, who is a philosopher, by the way, as well.
Yes.
Not only,
not only, but I'm a philosopher by education. Basically, I started my career as a philosopher, epistemologist, and system thinker, but I soon moved to exploring areas like artificial intelligence and more technical areas, where I have also established companies and I have established businesses as well. By the way, I'm very much interested in bioclimatic architecture. It is something that I have also, in a way, worked in a part of my career. I have also collaborated with architects and architectural firms that have designed buildings that work with nature, considering natural constraints and trying to leverage these constraints to optimize energy consumption and also comfort inside buildings for living purposes, of course. I'd like to understand which of the questions exactly, Roberto, you would like me to answer. I think that you are referring to the more technical, let's say, the last part of questions regarding the materials the cells could be made of, right? Can you confirm this, Roberto?
Yes, Sergio, yes, I was asking something like this, yes.
Yes. If you are referring to this, I must say that we are currently in the early stage phase of development of this technology. So we are currently exploring different possible trajectories in terms of technology to be employed to build the cells themselves. And we are exploring basically two possible directions. The first one is building microscale cells with hydrophobic materials, made of hydrophobic materials that can be injected with water and hydrogels, then seal them and have all the microcircuitry printed like 3D, like printed electronics does. We have been exploring different techniques do this, and we are in talks with partners that do provide microscale additive manufacturing for our purpose. So this is one line of development, and this actually does not require costly materials, of course, but the process is quite complex by itself. On the other hand, we are exploring also another direction, which is based on the idea of having directly the hydrogels that compose the cells printed and then insulated. So these two approaches are basically very similar, but also have important differences that we have to consider. And in both cases, the materials are low cost and are mostly ubiquitous. We are not resorting to costly metals for this purpose. And we are confident that we will find a solution by design that will meet both efficiency and sustainability constraints for the product that we want to develop. But again, we are in the early stage phase of development, so we cannot answer your question fully. We can just say that we are moving along a trajectory or a set of trajectories that will, in the end, will, with high probability, allow us to make this thing real and useful, as we have been discussing so far. So I don't know if this answers your question, but I hope so.
Thank you very much, Graziano. So now I'm very curious about the questions by Martha, because she looks at us from such a distant place. She has been working in Italy too. She is an international scholar and researcher, and she worked with the world of agriculture, the world of nature, where there is this direct interaction with ecology. Coming from Guatemala, I think it's very important because usually countries coming from South America, Africa, etc., are those who pay more the cost of this climate change and disruption that our model imposed to the world. So it's very interesting. They're producing a lot of ideas, and so they have a critical eye on this. So Martha, up to you, please.
Thank you, Stefano. Good evening to each of you. Thank you, Roberto and Graziano, for all the information. This is very exciting. And yes, precisely, coming from developing countries and facing all the needs on food, water, all regarding energy, education, and about that, I think this has a huge potential, particularly in agricultural production. But I would like to know more about what is the condition of the residual water coming out from this system in terms of being feasible for nature again, or even for humans to be used. Is there any kind of pollution on water after it's used on the system because of the heating, or if it is not? The next question will be, how do we make this scalable and reachable to communities on the field? Like some of the previous speakers said, the areas in which we work, remote areas, we don't have access to technology, innovation materials, or even education systems. So how do we scale up and make it reachable? My first thought was to involve private sector and governments in order for them to make it sustainable and accessible and approachable in the long term. I know this is a question for the future, but I think this is a result that is very much urgent for parts of the world, like where we are. So I will leave it with those two. And my last one will be in terms of maintenance in the long term. So we are expecting these systems to function in the long term. So what do we need to make it work in the long term? So that will be it. Thank you very much again for everything.
Yes, before answering these very interesting questions, I think that I will answer some of them and Graziano Terenzi some other of them. I would like to show to you the video that before I was not able to show, because it is very interesting to understand the very simple mechanism, the very simple behavior. If we have 3 minutes, what do you say, Stefano?
Go ahead, go ahead.
Okay. Of the oxidroelectric. Here is
The audio is very bad, Roberto. Maybe you can comment yourself.
okay, so I will comment. You can see this is the small cylinder that I was showing to you. In this moment, we have 138 millivolt at 50 kilo ohm resistor, and we have at ambient temperature something like 25 degrees. Okay, now I will switch on. I will add an infrared light. Exactly, you can see that exactly in the moment I was switching on the lamp, the extraction of current was immediately going up. You can see the graphic. Now I will switch off, and when I switch off immediately, it is extracting less current, and it is in a certain time it is coming back. Now I switch on again, and you can see the extraction of the current again going up. This is interesting to see how the phenomenon is immediate. Okay, now I switch off. The same phenomenon is happening in a large beaker, half-liter beaker. This means that it is in a radiation phenomenon, not a thermal phenomenon. This is very important because it is impossible for the water to heat immediately when switch on the lamp. But the same rapidity you can see also in a very, very large cell. Okay, only to explain because somebody can think, okay, it is probably thermal phenomenon and so on. And it is very, very stable. It is very important. So, considering the questions, in general, I can answer that you know that the gels, you have also gels that you can do normally sweets with with gels. No, it is something very, very natural, organic. So it is a material totally not polluting. And the water probably we can use hydrogen that are not so liquid finally. So we hope to obtain this mechanism with hydrogen with a small quantity of water inside, and that you have not to change the water inside, probably. And probably the idea is to seal the cell, to seal in such a way that the water is not evaporating, or to find an equilibrium with the ambient humidity, for example. We have to develop all this technology to go deeply. Well, that's why we need now 1 million euro of investments in this phase for 2 years of work about this, because we have to go from technology readiness level about 3, 4 to a technology readiness level about 7. This is our objective. I don't know if Graziano wants to say something more about this question.
Well, actually, I think that there was another set of questions by Martha regarding the scalability of the system, of the technology, and the possibility to applicate or relying on these technologies in countries, in developing countries, in different parts of the world. So I think that the first part of the question regarding scalability is basically answered by Roberto, as he says that we have yet to make this system scalable. We are in a phase where we have not yet a scalable solution, not because the system is not scalable by its own, because actually it is, and it is important to understand that in one cubic centimeter of water, you have the electric charge of 200 lightning bolts.
Yes.
So basically, we have the possibility, at least theoretically, to extract a very large amount of energy from small cells of water. It is
also the infrared density at room temperature is so high that if you perform some calculation, you can understand that you can perform a miniaturization.
Yes, yes, indeed. Basically, according to our estimates, we have found that we can reach a 30% efficiency of our system just by bringing the system to the millimeter scale, not under the millimeter. So basically, it will be way more efficient than most of the renewable energy system available today. So this is very important finding, and this is quite promising technology. The challenge is to be able to miniaturize the system and make applications out of the miniaturized system that can be employed as components in construction, for example. What Roberto was saying basically refers to the fact that once we have engineered the system and further developed it, we could include systems like this in components that you can use to build houses, to build offices, to build schools, to build hospitals. And you can do this by creating a sort of decentralized energy supply system that does not force the building to be connected to a costly network, okay, and energy power generation system and power distribution system. So this would be a cornerstone for a revolution also in developing countries or in remote areas. And I think that we should find a way to move forward along this path, because in the end we will be able to provide a lot of communities with a new way and a new system for generating power and electricity, and that could be totally independent of the central systems for power generation that we are basically tied today with. Okay, so I think that this can be kind of reply to your question.
Martha is adding a comment about this could be offered in the carbon market as an alternative to prevent deforestation for energy purposes. I would add also a final note that it's really impressive to me. We are talking about this subject, something that you're studying for 20 years, and we are in the midst of a war. So there are wars around the world for energy, and PD that niche votes couldn't join, but it would be a breakthrough idea about self-production of energy without a centralization. That's key. So, I mean, even a community in the Amazonas could produce energy by water with this system, and with not a big need for money. So it's shocking to see that we have minds and intelligence working at a certain level and producing solutions that can be current. And on the other side, we have the folly of the world in which we live. So my best wishes for your work. The ISB is trying to give its little contribution to your work by showing it to people that we think may be key for their development, especially in architecture and the way of thinking cities, because thinking cities means also things about politics, no? It's not just about houses, it's something much more important. And the energy has a role in that is absolutely key. So we'll keep updated. Thank you very much. I don't know if there is somebody else who want to add some comments or questions. And in case not, I thank you very much, Roberto Germano, Graziano Terenzi, Martha María Ríos, and Sergio Los, and of course, Professor Guido Dalla Casa, who surprised me coming to the meeting, and I'm very pleased by that.
Thank you.
Thank you very much.
Very much.
Thank you. Have a nice evening, everyone. Nice meeting you.
Thank you.
It's up to you to close the meeting, Roberto, because you are.
Okay, I will do.
Bye.
Bye. Thank you very much.